Hi. Well, morning. Welcome back from the coffee. We have Doug Sillars here that he's gonna teach us how to deliver our videos without errors of buffering.
Thanks so much. Can you guys hear me all right? I can't tell if this is all right. I'm probably loud enough for this room anyway, but thanks for coming, walking all the way over here from the coffee. So I appreciate you coming on over to talk a little bit about video. A little bit about me. I'm originally from the States, but I've been traveling with my family for the last 2 years as a digital nomad, so we've been traveling all around Europe. They're up in Sweden right now, so I came down for the conference. But I do developer relations, so I help companies reach out to developer communities, figure out their path to talk to developer communities. And I also work a lot in performance, speeding up websites, speeding up mobile apps, whether it's images, video, or just general performance, JavaScript, all that other stuff as well. I wrote a book about Android apps, and if you're interested, that's the PDF. I'll post the slides later, so any URLs you can get later. I'll put them out and I'll tweet them, and I think they're all going to get shared on the website as well. And then if you ever have any questions about performance or developer relations or any of that, I'm the only Doug Sillars on the internet, so I'm really easy to find. But today we're going to talk about video. And as we all know, like, video traffic on the web is just growing like crazy, right? And so there are all these graphs showing that it's just going to be exabytes and exabytes of data, and you hear all these statistics about how much of the internet is Netflix during during the evening, right? We all know that video is going nuts and growing like crazy. The trick is when we think about things that are delivered over networks, video is the largest thing by far of any object that you're ever going to deliver on the internet. And late last year, I had the opportunity to go to Moscow for a conference, and I was carrying an Irish SIM at that point. I was like, I wonder what roaming costs will be if I go to Russia with my Irish SIM. It turns out it was 10 euros a megabyte. So we're going to judge everything when we talk about how big the video files are, is like how much of a mortgage payment it is if you watch the video when you're in Russia, right? Because a typical web page is going to be like 30 euros, right? That's like dinner for a couple people. So we want to take that as an example. Now, I know this is an edge case, right? Most people aren't roaming on a data plan that's exorbitantly expensive when they load your web page, but it is an edge case. People will do this, and it will be very expensive. So what I did when I was trying to figure out how video is being delivered today is I did a study of the web. Does anyone know web page test? Any hands? I see a few nods. So web page test is this open source tool that lets you see how fast your web page is. You can test it anywhere around the world. I'll talk about that in a second. And there's a thing called the HTTP archive, and what that does is it basically runs web page test every month on like 4 million websites. And so you get this huge database of data about how these web pages are loading, and you can look to see how different people are delivering different content. And so this is web page test, right? You put in your web page. Here I'm testing in Virginia in America because they have real devices there. So when I test on it, when this says Moto G4, this is actually a real device. The guy who runs web page test name is Pat Meenan, and he has all these devices in his basement, right next to the furnace. And so it's really a Motorola G4. You can throttle the speed. So I test at 3G, just because that's a good thing to think about when you think about testing. Not everybody's on a super fast connection, so I like to test on a slightly slower connection. You know how it is when you go out into the country, you go somewhere else, or even standing in line for coffee when there's 150 other people on their phones, right? It was congested and really slow. And then you test the website. And so a few months ago, I tested the Webpack website, and the yellow lines means a redirect. And so what was happening, if you ever go to the Webpack website, at the bottom of the page, they have images of every single person who's donated money, right? And so there's a lot of images, which is great, means a lot of people have donated money. And the API that they use made a change in September of last year, and it ended up creating a redirect for every single image. So there was a request for the image, and then a redirect and a request for a second image. So I don't know if you can see it, but there was actually 1,100 requests when this page loaded, right? So we went and I helped them fix this. And now all those redirects are gone, but you can see there's all this information that web page test gives us. Taking that and taking it out to millions of websites, we can see This is 500,000 websites, but we can see that the use of video on the homepage of different web pages is growing. It's still small, right? 5%, but it's still growing, right? I expect this to continue growing faster and faster as more and more people add video to their web pages. When you add video to the web, speed index is a thing in web page tests. It measures how fast a page loads. It's measured in milliseconds. And if you have a page with video, the median load time on mobile is 11.5 seconds, whereas any other site is 7.5 seconds. So because video files are so big, we're already dealing with like 4 or 5 seconds, added load time. And all of the data out there shows that the longer a page takes to load, the more you lose customers. They don't stick around because it just takes so long. Now, what makes it take longer for video to load? Well, the median page here is 1.2 megabytes, and the median page here is 7 megabytes. So obviously, we're downloading a lot more stuff. But if we look, it's not all video, right? It's only 2.5 megabytes of video. The problem is when you have a web page with video, you tend to have lots of other cool interactive stuff like 1.5 megabytes of images, double the JavaScript, double the CSS, all those things. All of that takes time and adds to the time for the page to load. We're going to focus on video today. The top domains that were delivering video, you see Akamai, you see Google, you see Cloudinary, Amazon, CloudFront. What was surprising to me is the #1 video domain delivering video was Facebook on all of the web pages. And we'll get back to that, but you can see 67% of all of the requests were coming out of Facebook. So what was going on there? We'll talk about that. It's actually a bug in Chrome, or maybe a bug in Facebook. It's hard to tell. All right, but let's look at the metrics that they use, that video people use when they're looking at how video gets delivered. The first thing is, did the video start? And you'd think that's kind of basic, but it's actually a really important metric, and we'll get to that in a second. Did the video stall, right? If a video stops playing, obviously people get frustrated and they stop watching. And then did it look good? And if we optimize the content that we're delivering over the network, my hypothesis is that the video will start up faster, it won't stall as often, and it'll look good because we've optimized it for the mobile device. A lot of the research out there shows that people get really frustrated when a video doesn't start or it gets stalled. And there's actually this great study from about 5 or 6 years ago where people admitted to throwing their phones when a web page didn't load, and so hence the cracked screen. But here's some real data. So this is Q3 of last year. This is Conviva, and the inner ring is mobile, the outer ring is desktop, and you can actually see that like 2 to 4% of videos actually fail to start. So someone presses play and it never works, right? If we were building web pages and we failed, 3% of the time, I mean, that would be really bad. But then we also see that 16% on mobile and like 27% on desktop, which is crazy to me. People actually press play. It would have worked, but they weren't patient enough for it to start, right? It took too long, and so people abandoned the video from playing. And so that's really important, right? If there's video on a page, but it's loading, but no one ever sees it, it didn't really ever play. I mean, that's kind of useless. And just think about that. Again, if we were building web pages and it failed, almost 20% of the time, this is a big deal, right? We need to make sure that when we're delivering video on mobile or on desktop, that it actually plays so that people can see it. Let's focus on why video doesn't even start up. And so I went through the HTTP archive and I found, my fair share of 404s and 500 errors and things like that. That happens. It's unfortunate, it happens. But I think most of them are things like this, right? Where you click a link, you're like, yes, I can watch the video. And they're like, oh, I can't watch the video, right? Because it's geolocation, right? They know that we're in Spain. This is a broadcast only for the United States. Oops. This isn't an ideal user experience. From a user experience perspective, I think Amazon does this right. So I have a US Amazon video account, and when I fire up the app, it says, oh, you're in Spain, it looks like you're traveling. Here are the videos you can watch. And when you get back to the States, here are all the videos you can watch when you get back to the States. I don't click the button and see this, right? false expectations, and then disappointment. And then further, it's 231 requests and 3.1 megabytes of data to tell me, oops, right? It didn't take 18 seconds, but they've got a beacon basically telling the server it's not working, and I was just really slow on catching the screenshot. So there's an easy way to fix video not working, I think, in general. But what about these videos that where someone presses play, it should have worked, but it never actually started playing? There's actually been research on this. Basically, if you press play as a user, everyone will wait 2 seconds. 100% of people will hang out for 2 seconds. But after 2 seconds, you lose about 6% of your viewers every additional second. So the longer it takes for the video to start up, the fewer people will actually watch the video. It depends what type of video you're watching. If you're watching a short video like a cat dressed up like a shark on a Roomba chasing a duck, right? After 3 seconds, you're like, what? You start questioning your life choices and you abandon, right? People abandon the short videos a lot faster. Whereas if you're sitting down to watch an hour-long TV show or a 20-minute TV show or Star Wars, right? You're already dedicating a whole bunch of time. What's an extra 4 or 5 seconds? So people who are watching long play videos hang on for a little bit longer. But if we look on the web, we see of these 500,000 websites, 36,000 on mobile had video, 55,000 on desktop had video. And as you might imagine, the overlap is really, really good, right? Most of the sites that have video on desktop also have it on mobile. But what was really interesting is that 19% of the videos are the exact same file for desktop and for mobile. And so, of course, what that means is either the video is optimized for mobile and it starts up really, really fast on the desktop. How many people think that's what's going on? No, you're serving the desktop stuff. It looks really good on the desktop and takes forever to start up on a mobile device. So there's things that we need to think about here. It's not one size fits all here. It's just like images, right? We all know you don't serve a giant image down to mobile device. It's the same thing with video, just on a scale of like 10 times larger. When we think about optimizing images, this is Josephine, one of my goats back in Seattle. You can optimize this image. So the original image was 2.5 megabytes. I can lower the quality of the image, and there are a bunch of ways you can do that. I can lower the quality to 85%. There's a thing called structural similarity, which is just an algorithm that squeezes out a little bit more, and as a human, we can't tell the difference. I can save it as a WebP. If you're using Chrome or Firefox or Edge, it's not in Safari yet, or on Android. And so I'm using Cloudinary here, so I just uploaded the full-size image. I changed the quality, I changed the format, I changed the width, and I take that image from 2.5 megabytes down to 204 kilobytes, which is a lot more reasonable. Probably still a little large, but we're doing a lot better. So let's look at image optimization on the web, again from the HTTP archive. This is the percentile of websites. This is megabytes of video, or megabytes of images. And you can see in general, we're serving less data to mobile devices than to desktop, as we probably should. It's not a huge difference. It probably should be bigger. Then we're going to do the same thing with video. First thing to notice is look at the axis. It's 10 times larger. Right? There's some websites serving a lot of video. And if you actually look, the gray line is mobile. On some of these websites, they're serving more video to mobile than they are to desktop, right? We've got our parameters are a little bit out of whack here. So let's talk a little bit about video. This is Nora. And when you have video, you obviously have a bunch of different images, and then you have an audio track. And so what's really cool about video is that there's compression on both each frame and then across frames. And the way compression works across frames is through groups of pictures. This is like completely watered down with no math. But basically, the greens are full frames. The pink or the red are half size, so 50%. And then in between is 25%. And there's a bunch of math and vectors to make sure that you're doing compression. And so these aren't full-size images, and so you get a lot of compression. Videos are a lot smaller. And rather than do the math, I thought it'd be fun. You can see the vectors. So those are the P frames, right? It's showing the vectors. This is where all the compression is happening. You can see the B frames. This is the 25%. These frames are 25% smaller. You can put it all together, you can see there's a whole lot of compression as Nora eats the leaf. Animated GIFs are the exact opposite of this. Right? We all get excited when we think about animated GIFs, but if you go back to 1990, right, ancient times in the World Wide Web, the graphics interchange format is not intended as a platform for animation. This is in the spec. The spec says, don't use animated GIFs, right? And luckily, most of the web does not use animated GIFs, and we'll talk about why that is. It's sort of animated GIF, the format, versus animated GIF, the medium. The medium is good, right? Looping video is really, really cool. The format isn't so great. And so here's why. That video of Nora the goat is 1.4 megabytes. I took it with my phone, super cool. I turned it into a GIF, and it's 270% larger. And the only reason for that is that there's no compression. It's literally a flip book of GIFs, right? So if you have 15 frames per second, it's 15 GIFs that it's just like over and over and over again. So what did I do? Well, I turned it, GIFs are 256 colors because 1990. I stripped out the audio track because goats eating is kind of a gross sound anyway, and GIFs are silent. So it's 250K. And so then I can serve that, and it's a lot smaller than even the original video because I stripped out all those colors, right? But what about on the web, right? Like this is a tweet, and it says, it's a GIF, right? No, they're lying. It's not a GIF. Twitter does not serve GIFs. You can open up in DevTools, and there it is. It's an MP4, right? So Slack, Twitter, Facebook, when they say they're giving you a GIF, they're lying to you. It's GIF the medium, not GIF the format. And the reason for that is you can't really see it, but that's 390 kilobytes, whereas if this was a GIF, it'd be like 2.5 megabytes, right? So you're talking just about delivery time. Delivering a video is way faster, so we want to do that. So how do you do it? Video tag, loop, autoplay. On mobile, you have to put muted. And the reason you have to put muted is that Chrome engineers and Safari engineers sit in meetings too. And every now and then, And if the video's loud, they're busted. Right, we're all busted. So you have to have muted for it to play on mobile. The other thing you can do that's actually really cool, and this is Safari only, is you can actually put videos in the picture tag. So right here, if it's in Safari, it'll grab the GOAT MP4, 250K. If I'm on Chrome, it'll grab an animated WebP, right, 3 megabytes. And for everybody else, you get the animated GIF at 3.8 megabytes. So from a performance perspective, I took that slide out. All right, this is like 4 seconds. This is like 20 seconds, right, for delivery time. So if you want to do that in Safari, that's a pretty cool way to do it. It doesn't help everybody else, whereas video would do that. This works in every browser, so it's a good thing to do. When we look at video that's on the web, most of them are MP4s. And that's sort of interesting because if you think about YouTube, you think about Netflix, all of those, they're all streaming the video. These are streaming files, TS, those are HLS files. But most of the web is actually MP4s. They're just, popping on MP4 onto the web page. And is that the most efficient way to do things? Well, we'll talk about that. This is MajorLeagueBaseball.com. It's the Red Sox. This video right here on desktop is the same as this video here on mobile. It's 17.6 megabytes, right? This is a recap of an entire baseball game. Baseball games are 2-3 hours long, so a 83-second long video, that's not all that bad, right? It's 17 megabytes, it's 960 by 540. What can we do to make it smaller? Well, we could lower the bit rate. Where's my click? Yeah, if we downscale the bit rate a little bit, to 1.37 megabits per second. Again, I'm just using Cloudinary because you can upload the full video and then just change parameters in the URL and it does it for you. This lowers the quality of the video a little bit. It lowers the audio track a little bit. I mean, it's going to be a baseball announcer speaking. We're not looking for like high fidelity sound here. I make the video 13 megabytes, still a little large. It's not ideal, but it's 22% smaller. Whoa, I don't know what button I hit there. That was cool. I won't do that again. I could downscale it For mobile, so on mobile, maybe I only serve the 6.4 megabyte version. You have to do a little bit of JavaScript there for screen size to serve the right size file. But if you think about just storage on the web, this is 19 megabytes at 17. You haven't really increased the amount of file space you're using, but you've improved the experience, the load time to the different devices. And honestly, for a half-screen video like that, you probably won't notice the difference by downscaling the video that much. Other things that I've seen websites do, this is a web page where on desktop it downloads 267K of video. On mobile, it downloads double, 566. And so why does it do that? Well, interestingly, the way the HTTP archive works is this is not a Retina display, and that one is a Retina display, so it's downloading the Retina version of the video. You can see it's at 2x.webm. And you can go into the code, and you can see that, yeah, if it's Retina, it's going to serve the Retina version of the video. This is a silly little animation that you can't tell the difference whether it's Retina or regular. So like if you're going to serve Retina content, you should probably make sure that it's worthwhile. And then probably more importantly, if your CSS is going to block the video for the mobile devices, we probably shouldn't download any video at all. So here we are, we're downloading 0.5 megabyte of Retina-sized video that never actually shows up on the screen. Another thing you can do with video, there's a parameter in the video tag, preload equals auto. And if you set that, the browser automatically downloads the entire video. So I went to this web page, and you can see this is the web page test waterfall. And then the last thing to download is the video. And you can see in this case, it downloads the entire video. That ends up being 23.5 megabytes of video, or 236 euros if I'm in Russia, right? I didn't ask for this video. It's way at the bottom of the page, but it downloaded the entire video because they thought that was the right thing to do. This is great if like 90% of your viewers are going to watch the video. But if like 5% are going to do it, you're going to end up spending a lot of money in transmission costs just out of your data center, right? You have to have a lot more capacity because I don't know, like it's 8 times larger a website because you're doing that, 10 times larger a website. It's really big. So you only do that if they're really going to watch the video. The default parameter in Chrome is preload equals metadata. So if you just put a video up, Chrome will automatically do metadata. And so here it downloads the first 2 or 3% of the video. So here's another waterfall where it's doing preload equals metadata. The green line is the video. And so you can see there's this giant download happening. You can see it's just one request, one video request, but it ends up being 2.7 megabytes. And the reason for this is, of course, the video that they had up on the web page was 2.5 minutes, it's 1080p, and it's a 97 megabyte video, right? I'd argue that a 97 megabyte video is probably a little bit large for desktop or for mobile. And so let's see where that is on the web page. So this is the mobile web page. You can see these are about the first 8 views, the first 15 views. There's the video. How many people are going to go scroll that far down on the mobile web page to A, find the video, and then B, press play? No one. No one is. So you should probably actually set preload equals none here, right? And so then it'll never actually download the video. So use this with discretion. And again, it's not all. I guess this one is 30 euros, so it's still a little bit expensive. So again, avoid auto unless it's high probability metadata, medium probability to play. Otherwise, you'd probably set it to none. Background videos. We've seen this on web pages. There's a lot of research out there saying that background videos increase engagement by like 80%. Those are written by marketing companies trying to get you to use background videos, so grain of salt with all of that. But like this looks really cool, right? You can go, I want to take my kids there, right? This looks really, really great. So the video is 5.3 megabytes, and that, it's big. It's not outrageously horrible. But then I started looking at it, and 250 kilobytes of that video is audio. Well, background videos don't have audio, right? So a tree falls in the woods, doesn't make a sound. This is a video that's downloading the sound but not playing it. Really easy optimization to make the file 5% smaller is to strip out the audio track. So if you can do that, animated GIFs, right? The looping videos, remove the audio track. Background videos, remove the audio track. It'll make the file smaller. You can't actually just silence the audio track because there will still be like an empty track that still takes up space. You have to actually specifically remove the stream. It's pretty easy to do though. Another background video that I've found, so then the same thing happens when you look at it on mobile. The video downloads, but it's hidden. So you get a fallback image, so you don't actually ever see the video, but it's downloading. And then to make things worse, they have a fallback JPEG that's 900 kilobytes, and they don't use that either. So you're downloading the video, you're downloading the fallback JPEG, and you don't see any of those, right? Because they hide the fallback. Test your stuff, guys. I guess that's the main thing here. Here's another background video. If you're on a really fast connection, you'll see this background video. This is what the video looks like. The first thing we learn is that Bob Ross was also a photographer. But this video, the reason you never see it on the web page is it is 33 megabytes. It's 27 seconds long. It's 2,500 pixels wide by 1,200 pixels high, and it's 10 megabits per second. Right? This is a ginormous video. So resize your video to a reasonable size, right? A pro tip, if you rename the file 720p, that doesn't actually re-encode the file to 720p. You actually have to go and re-encode the file. It is new. It is new. So what I did is I took the file, I uploaded it, and I resized it to a bunch of different sizes. Again, I use Cloudinary because it's super easy. Width 720 is 4.3 megabytes, right? Even at 1080p, it's 8 megabytes. It's still huge, but it's not 33, right? It's 4x smaller. So you can see just by resizing the video, I did a lot of optimizations just to make this video show up a lot faster. On mobile, yep, you guessed it, don't do that, all right. I sort of alluded to this, that video isn't cheap. Anyone know Garth Brooks here? Country music singer from America. I see a hand, all right. So this is his webpage, and when you load up his webpage, you get Garth Brooks singing, right? That's really awesome, that's a great idea. You can't really see it here, but on my computer, I have like this thing that shows you how fast you can speed up the video. There's actually a background video playing over this, behind this video, so you've got two videos playing simultaneously. So you can see, here's the video of Garth Brooks singing, it's 51 megabytes. You get this background video that's 7 megabytes. And then, of course, there's an animated GIF that's 6.2 megabytes right below there saying his new album is coming out. That's all great. They're all being served out of S3, which is also great. S3, you know, it's a simple web hosting service, but it's not free. S3 costs 9 cents a gigabyte. So if you have 51 megabytes being downloaded, or 51 plus 7 plus 6, so we're at like 65 megabytes, right? That's half a penny every single time this web page loads in S3 costs, right? That can get pretty expensive pretty quickly if you get a lot of people hitting that website. Like the new album comes out, it gets on Twitter or whatever, and people start hitting the web page. Like you could have some pretty extensive server costs there. Add to that, in Chrome, there's a bug that I filed. But if large videos aren't read from cache, they're just repeatedly downloaded. So if you leave this web page open for a long period of time, yeah, you can download the video like this, 2.5 cents in S3 server costs, just by leaving the web page open for 20 minutes, right? I mean, this isn't, you're not going to really, like, you're not going to make Garth Brooks go broke by doing this, but like, still, there's a cost associated with this. So far, we've talked about a bunch of different things. You know, don't use Retina unless you need to. If the video isn't going to show up on mobile, don't display it. Avoid preload equals auto. Strip out the audio track if it's silent. Big files can cost a lot of money, and it really just comes down to respect your user's data plans. So Can you be responsive? So we talked a little bit about responsive images, where you serve the right size image for the right size device. And the whole idea is you can do that with streaming video, right? If you have a bunch of different streams, you can serve the right size video to your users. And the way that works is in a streaming video. This is HLS streaming. MPEG-Dash works much the same way. You have a manifest file, and it's sort of a menu. It lists all of the streams that are available. That gets sent to a player in the browser. It picks a stream. It starts getting a bunch of segments, which are like 2 to 5 second chunks of video. They start downloading them, and that's what this is, right? That's the buffer, right? That's how it's on your phone, so it's not going to stall. And then the video plays. And then as the video's playing, the player can start estimating how fast the files are downloading, and if it can do better, get a better quality, it will download a higher quality video. And you've seen this, right? When you're watching a video and it looks all really pixelated at first, and then about 4 seconds it snaps into something looking nice, they're downloading the lowest quality first. Why? It'll start up faster, right? I mean, they've thought this through. And then once it's figured out the right network, it'll serve the right size video. So this is what a manifest looks like. This is from a TED Talk. So these are all the video tracks. That's if they're in an iframe. And then this is the audio track, and then all of the subtitles. And so what's cool here is the TED Talks have like subtitles in a zillion different languages, which is kind of neat. This TED Talk was actually in Japanese. It's really interesting. The first option, and the way these are read when you change the subtitle, is they're in order. It always goes in order. So the first choice here is Greek. Greek, English, Vietnamese, Italian, Arabic. Like, I'm not sure exactly how they figured out that order, but like that's the order that it's in. Spanish is right here. So you're in the top third, I guess. But it's been translated in Malaysian, Polish, Swedish, everything, right? But we're going to just talk about the video tracks here. And so what you see for each one of these, this is just zoomed in, you get a bunch of information. This is the audio track to play. This is the bit rate of the video, 1.4 megabytes, megabit per second. The codec, the resolution is 640 by 360. And then this is the link to where all the files are stored, so you can start downloading them. I can figure out the first TS file is always going to be the same, whether it's desktop or mobile. It's going to download the first stream identically. 2,000 of them are the same. I'm not sure that slide is out of order. All right. Anyway, so this is a website that I found. This is learning the website where you go to get a driver's permit in Argentina. And this is the video that's played there. And this is true for desktop or for mobile. The first segment it tries to download is 37 megabits per second. That's not going to play anywhere. And it's going to use a crap load of data because it has to download the first segment at 37 megabits per second before it decides to drop down to something a lot lower that's actually going to play on any device, whether it's desktop or mobile. So in general, you shouldn't start off with something that's going to take forever to start up because that's going to prevent the video from playing. What happens if it picks that high bit rate stream? It tries to start downloading that 37 megabit per second stream. It takes forever, and the player knows it can't wait forever, so it chooses a different bit rate. The buffer starts filling up, and the video starts playing, right? So that's what's supposed to happen, but we added this whole step of congestion beforehand, which is going to slow down the video startup, which is bad. Okay, so what actually happens, in this case, it downloaded 1.2 megabytes of that first file before it gave up. It actually didn't download the whole file. But that's still €10 if I wanted to learn to drive in Argentina when I'm in Russia. But video startup, again, this is older data, but we saw 16% fail on mobile and 27% fail. This is from Q1, it was 12%. It's all about the same, right? People are not watching the video when it starts up because it takes too long. So I alluded to this earlier. If you start with the lowest bit rate, you start here, the player eventually finds that better bit rate. So it starts up really, really fast, and then you get a nice quality video 4 or 5 seconds in. The other option, which is sort of what's happening in that Argentina example, is you start with this really high bit rate. It doesn't play, right? You've added one more step, right? So that's going to be slower. You're going to lose viewers. Interestingly, there's this approach, and this is what Amazon does. They start with sort of, I call it the Goldilocks approach. They start with the middle bit rate. It takes a couple seconds longer to start up, but it's really high quality from the very beginning. That probably works for Amazon because it's a long play video, right? People hang out longer for long play videos, so they'll hang out longer. From the very beginning, it looks great. And if you use Amazon, if you ever watch one of their Amazon originals, no, that's Netflix. It's original, Prime originals or something, right? Anyway, whenever you watch one of those, it doesn't start with a black screen. It starts full color, and it's always super sharp from the very beginning. So that's one of the ways they differentiate. It always looks really great from the very start. We can load all these up in web page test. We can compare them. You can see when you start at the lowest bit rate, the video shows up first. In this case, out there at 17 seconds, oh, I have a laser. That's the same quality as this one, but it just took 6 seconds longer. So don't start with the highest quality. And so this is sort of the Amazon example. It took about 3 seconds longer, but it's high quality. So there's your trade-off, right? You can decide whether that's worthwhile. When you start off with this highest bit rate, it's going to look really great on super fast devices. Otherwise, it's going to look really bad and start off slow. This is probably your ideal for fast startup, but you have that initial low quality. And then the Amazon approach where your initial quality is good, but it takes a little bit longer. Okay, so when you have a manifest file, in this case, this is again the TED Talk. And what's really cool here is the video is all in green and the audio is in gray. And what's cool about that is if you separate out the audio tracks, what if you have different dubbings? You can specify which audio track to play. So you can play it in Spanish, you can play it in German, you can play it in English without changing the video at all. You can just swap out the audio track. But here's this TED Talk. It starts off with this high bit rate, sort of like that. It's sort of that middle approach, but sort of not. And when I'm testing it with web page tests on a 3G connection, well, I have to point that there. That's confusing. All right. You know when you start a TED Talk, you get that intro with it's the TED Talk sound. Like I was testing this and my kids were like, Dad, you're watching a lot of TED Talks, because it was playing the TED Talk sound. That's this intro. It's called Thousands. And when I start the video, it starts off here, but then it quickly drops to this lowest quality bit rate, and it never recovers. It looks fuzzy while I'm watching the video. So what's going on? Well, I went back and I started looking at this, and you can see it says the manifest is saying that first bit rate is 1.4 megabytes per second, but the video is actually 600 kilobits per second. Why are they doing that? Well, when you do it this way, the buffer fills up twice as fast as the player thinks it will, so the video isn't going to stall, right? But we're lowering the quality by accident. So what I did is I just changed all the bandwidths to match the bit rates. So this is probably the other side. Highest quality, it will stall more often. There's probably a sweet spot somewhere in the middle, but just as an example, we're just going to go to the other extreme. The first thing you'll notice is my y-axis changes to about half what it was before, right? From 1.4 to 600. I tested again. Interestingly, I still dropped to that really low bit rate at the beginning, but then quickly, this is the intro. By the time the TED Talks really kicked off, I'm back to this initial bit rate, so it's a pretty good quality. But I was still confused. Like, I know I'm running my network speed up here, right? I know I have the bit rate to handle this. So what the heck is going on? Why is it dropping to this low bit rate? So I dug a little bit deeper. This is the manifest file where it's actually choosing each segment of video. And so it's TED, bumper, thousands, a byte range of like 900 kilobytes. This is like 200 kilobytes. This one is like 20K. And this is how long each one of those playbacks is supposed to be. But if you look at this, this is 900K, 5 seconds, 200K, 7 seconds, right? Something's wrong with those numbers. I spent a lot of time trying to tweak the numbers and pulling out calculators and making them all work so that they were all appropriate. I could never get it to work right, and I said, screw it. We're just going to download the whole thing in one chunk, 12 seconds long, see what happens. And then I just left the rest of the TED Talk the same way. What's really cool is they add this bumper through a URL parameter. So if they just change the parameter, they can change the intro. It's all automated on their back end, which is really kind of neat. But when I do that, you can see the bit rate stays right here and then actually goes to a higher quality bit rate as the video starts playing. So I've improved the quality of the video. Now again, I've taken it to that extreme where it might stall more often, but we can probably find a spot in the middle where the bit rate still looks good and it's not going to stall very often. So that brings me to Ghostbusters. Why do I have Ghostbusters here? I plugged in the audio. We'll see if this actually works. It's not going to work. Maybe I need to turn up my audio on my computer. Anyway, you guys know the movie? All right. All right. So in this scene of the movie, they've got these things that they capture ghosts with. And they're like, all right, this is the first time we ever used it. The most important thing you have to learn here is never cross the streams. Because if you cross the streams, it total protonic reversibility, the end of the world, right? Don't ever do that. Anyway, it's an old movie. What happens if you have two streams on the same web page? So the player is trying to optimize the video quality based on the available bandwidth. If you have two streams downloading at the same time, if you've got 10 megabits per second, both of them only have 5, you're lowering the video quality for both of them. So in this case, this web page is downloading 2 TED Talks at the same time. It can't get the same quality video out for both of them because it's trying to download both videos at the same time. So don't download 2 videos at the same time. I actually found an example that is downloading 24 simultaneous streams. And to test this, I had to wait until 2 in the morning, like when all my neighbors went to sleep, because like the throughput on, it wasn't just my network connection, it's like I needed everyone to be asleep so that I could go out to the internet faster. But in 4 minutes, I blew through 245 megabytes of data on my mobile device on Wi-Fi, because you can't see it. Each one of these boxes is a stream. So it's trying to download like 24 streams and play them simultaneously at once. That's basically a mortgage payment, I think, at this point in Russia, right? I actually had to go into, one of these pages didn't actually work, like the broadband provider like blocked it and said it was malicious content. And there was no malicious content except for to the broadband provider because it's downloading 245 megabytes of data in 4 minutes. When I talk about video a lot, people ask me about third parties, like, why don't I just put it up all on YouTube or on Vimeo? And that's great. But as soon as you do that, you can expect about a megabyte of JavaScript and CSS and fonts and all that other stuff. It won't download any video initially, but to get the window ready, you have to download all the YouTube and Vimeo stuff to make it work. Back to Facebook. So why does Facebook, the hugest, download the most video files on the internet? And it turns out, like, if you embed your Facebook homepage on, like you've seen this, right? You go to a company's webpage and they've got their Facebook homepage here. In Chrome, and this is like a separate window that you can scroll in separately, any video in Chrome, any video on your Facebook feed that's embedded into Chrome, it downloads 30% of the video automatically. So again, like how many people actually go into the Facebook feed on the homepage to watch a video? Like nobody. But here it's downloading all these green lines or video files being downloaded. It's a bug in Facebook. It only happens on Chrome. They've said they're not going to fix it. So in conclusion, video files are really, really big. So if you ever put video, you should really spend a little bit extra time to audit it to make sure that you're going to make it as small as possible. So resize the videos. You can lower the quality, the bit rate, the dimensions of the video. If the video is going to be hidden, common sense. We saw this with images like 10 years ago, right? If there's images on the page but you don't show them on mobile, don't do it. Same thing with video. Strip out the audio track. Don't download the whole video. Start at the lower bit rate if you're streaming, so it'll start up fast. And then, use one video at a time. Don't cross the streams. And then audit your third parties. There are websites where you can add the video. They like share this video, and it's like one line of code. It's a div, and you paste it in the web page. It downloads the whole video automatically. So audit it. Like they made it really easy, but it could end up being a lot of data. So with that, thank you. I've written a bunch of blog posts on how to optimize video that goes into a little bit more detail than I could in 40 minutes of talking. And then if you're really interested in building things with video and with images, one of the Cloud Area started this media developer expert program, and they've got a bunch of things that can help you do that. So if you're interested, you can send them an email if you're interested. But with that, I'd be happy to take any questions with whatever time I have left, which probably isn't a lot.
We have time for just a couple of questions.
Great.
So, any questions here? No questions? Well, then again. Okay, one question.
Hello? Okay.
Yeah.
So sometimes I am watching a streaming, right?
Yeah.
Like there's a delay. I know there's a delay between what I'm receiving and what I'm watching because of the buffer.
Right.
Is there a way of saying to the player, like, don't buffer me anything, I want the video to stall, but I want to watch it like live?
So you're talking about live streaming versus
Yeah.
video on demand. So live streaming, I didn't even get to because that's like
So
a day-long workshop.
Okay.
This is all video on demand, stuff that's already been saved, you can watch later. Live streaming is really hard because there's obviously, like live TV has like a 10-second delay. So if you're watching it on TV, if you're watching a football match in a bar, in a pub next to the stadium, you hear the stadium explode, everyone's cheering, and then you look up at the TV and then you're like, yeah, right? Video on the computer is even worse. So if you're at home watching it, you hear the stadium go nuts, then you hear the pub downstairs go nuts, and then you're like,
Yeah.
30 seconds later, yeah, right? And so there's a lot of latency there. And so there's a lot of research working to optimize that. So a lot of it has to do with how long the segments are. For a long time, Apple required all segments to be 10 seconds long. So you have to record 10 seconds of video, encode it, and then deliver it. You're already probably 20 seconds behind just with that, right? And that's with no buffering. You want to build in a little buffer because there's nothing worse than watching a football match and then like, yeah, and you're like,
What?
and you're still watching the screen and they haven't even kicked the ball yet. And then by the time it recovers, the guy's got his shirt off and is like, and it's like everybody's on top of him, right? So you don't even know what happened, right? So you want some buffering because if you miss the goal, like you're pissed off, right? But you're right, if it's too much buffering, then you're a minute and a half behind. So there's a lot of research going in right now to figure out how to optimize that.
No time for more questions, so sorry.
I'll
Thank
be
you
around
again.
if you have any more questions, so feel free to.
Thank you so much.